everyone, welcome back to my YouTube channel. I'm Miss Merkin, and in this video we're going to go over special right triangles. So we have two different kinds of special right triangles. We have what we call a 45, 45, 90. So what that means is the three angles on this triangle are 45 degrees, another 45-degree angle, and a 90. So I'm going to label that on my diagram. So 45, 45, and this little square right here represents my 90-degree angle. Another name for this triangle is an isosceles right triangle because we have two legs that are the same length. And we know that because the legs that are opposite of these angles, they're the same angle measure. So the side opposite of those angles are going to have to be the same length. So here's our rule for special right triangles. We can actually very easily and very quickly calculate the missing side lengths, as long as we're given one, of these special right triangles. So if this length right here, this side is x units or x inches or whatever measurement you want to use, x units, then this one right here also has to be the same exact length. It's going to be x. Okay. Now, using Pythagorean Theorem, we can actually find in general how the length of the legs are related to the length of the hypotenuse. So if I say, well, x squared, leg squared, 1 squared, plus leg 2 squared, so plus x squared, equals my hypotenuse squared, I can actually find a pattern here. So x squared plus x squared is 2x squared, which equals my hypotenuse squared. Okay. And note, I'm going to try to solve for h, which is my hypotenuse. So I'm going to take the square root of both sides to get that h by itself. And so then I end up with the square root of 2x squared, which is equal to just h. Okay. Now I have a rule. When I'm taking the square root of two things that are multiplied, I can take the square root of them individually and then multiply them together. Well, square root of 2 is just root 2. The square root of x squared is x. So I have x root 2 equals my hypotenuse. So all you need to do, if you know the legs of a 45, 45, 90 right triangle, if you know the length, you automatically can find the length of the hypotenuse by just multiplying it by square root of 2. So this length right here would be x times the square root of 2. And I'm going to erase this just to clean it up. Let me grab a rag real quick. Okay. And if you want to, replay, rewind, whatever you need to do to see that again, you are welcome to. Okay. So for our 45, 45, 90, we have x, because the length of the legs are the same. And to get the hypotenuse, we just take the length of the leg and multiply it by the square root of 2. Alright, so our second special right triangle is a 30, 60, 90 right triangle. So we have our 90-degree angle right here where that little square is. We could label this as 30, this as 60. We also have a rule for this one. So you can kind of think of this 30, 60, 90 triangle as half of an equilateral triangle. If it were half of an equilateral triangle, this would be 60 degrees. This would be 30 degrees. And basically, it's just, this equilateral triangle just split in half. And on an equilateral triangle, all of my side lengths are equal and all of my angles are equal. So we can kind of denote that here. All of these side lengths are going to be the same. All of our angles on our equilateral triangle are all 60. Okay, so now Let's say that the side opposite of 30 degrees is x. We don't know what it is, but this side right here is x. Let me just center that a little better. Okay. Now, if we notice, this length right here is half of our total length. We also know that all of these sides are equal because it's an equilateral triangle. This chunk is half of an equilateral triangle. So if this is x, this would be double that, 2x, this would be 2x, and that would be 2x. So you take the shortest side, the side opposite of 30, if you have that length, you just multiply it by 2 to get the hypotenuse, or if you have the hypotenuse, you divide it by 2 to get the leg opposite of 30 degrees. Now we just need to get our last length right here, which we could actually use Pythagorean Theorem for. So if I do that, it's leg squared, which is x squared, plus my other leg squared. I'm just going to call it b for now. B squared equals my hypotenuse squared. Okay. X squared is just x squared, plus b squared is just b squared. 2x squared is 4x squared. Now for this, I'm actually solving for b, which is the length of this side right here. So I'm going to subtract x squared, sorry it's getting a little messy, from both sides. Then b squared is equal to 4x squared minus x squared, which is 3x squared. Okay. Now my final step to solve for b is take the square root of both sides to get that b by itself. So b equals the square root of 3x squared. Now we need to clean that up just a little bit. We have that rule that we can apply here. So b equals the square root of 3 times the square root of x squared. A square root undoes a square. So I'm left with b equals x root 3. So x root 3 would be the length of this guy. So I'm going to clean up this diagram just so we can see what our rule is for this. Oh, erased a little too much there. I will rewrite that. I'm going to even erase this whole little other half of our equilateral triangle as well. Let me rewrite some of this because I did a little too much erasing here. Okay, so if I know that the side length opposite of 30 degrees is x, I just double it to get my hypotenuse, and I multiply it by root 3 to get my longer leg. Okay, so let's actually see this in practice. I'm going to do two examples. One is going to be with a 45, 45, 90 triangle, and the other is going to be with a 30, 60, 90 triangle. All right, so here are two examples here. I'm going to show you how you can actually use these special right triangle rules to come up with missing side lengths on these types of triangles. Now, the reason this is useful is because, as you can see on this example here, I only know one of the side lengths, which means I can't use Pythagorean Theorem to solve for a missing side length because I need at least two. So we have to use our rule. What I like to do is just kind of draw out my rule. So if I had a little 45, 45, 90 triangle here, I know that my legs have to be the same, so they're both x. And if I take the length of my leg and multiply it by root 2, I get my hypotenuse. Okay, so for this one, I need to find my x's, in other words, the length of my legs. And to do that, well, I know that 5, which is the length of my hypotenuse, is equal to x root 2. Well, x, and then it's times root 2. To undo that, I just divide. So x equals 5 over root 2. Okay, so that means the length of my legs for this one is 5 over root 2 and 5 over root 2. Now, if you notice, we could check our work. We can multiply each of these lengths by root 2, and we'd end up back with 5 to get the length of our hypotenuse. Okay, so I'm going to clean this up so I can leave some room for my second example. I'm going to leave this up here though. Okay, so for this one, we have a 30, 60, 90 triangle. So I'm going to draw a mini one that has my rule there. So 30, 60, 90, okay. So for this one, if I knew the side opposite of 30 degrees, that's my x, I multiply it by 2, so 2x, to get my hypotenuse. And to get my longer leg, the one opposite of 60, I multiply by root 3, so x root 3. Okay, so 4 root 3 is actually equal to my x root 3. Once I find my x, I can find these two side lengths. Okay, so x root 3 is equal to 4 root 3. To get that x by itself, I need to divide both sides by root 3. So x equals 4. That means my side right here equals 4 units, the one opposite of 30. Okay? And then the last thing I need to do is find my 2x, right, which is the hypotenuse, which means I take a length right here, which is 4 in this case, multiply it by 2 to get 8 for my hypotenuse. And that is how we use our 45, 45, 90 and 30, 60, 90 rules to solve for missing side lengths on special right triangles.